last time we were looking at volcanoes, and this time around we are going to be shifting up and look at another thing. And this time around we are going to be looking at the world distribution of volcanoes. We had talked about areas that contain the volcanoes, and mentioned about the volcanic region. Then among the regions, we mainly looked at what we call the Iceland, being one of the regions that has got very many volcanic volcanoes. This time around, we are going to be looking at the different areas that have gotten volcanoes. We have what we call the Saturn Pacific Belts. This one is also known, or is what you can term as the Ring of Fire. Is a string of volcanoes and sites located on the most of the earth. A subduction of the zones having seismic activities around the edges of the Pacific Oceans. That those areas around the Pacific Oceans are associated with what we call volcanoes or raised mountains or hills. When you go on, they're talking about that the Pacific plates or plates hit other plates nearby and cause them to sink because of the convergence or because of the forces that may be created. You're saying now the crust melts, then producing the magma that feeds like different in terms of when you go on, they talk about that Pacific Ring of Fire. It helps to produce new volcanoes, and these rings of fire result from the plate tectonism or plate tectonics. In other words, that most tectonic activities in the ring of fire occur in these geographical activity zones. So they are trying to mean that in those areas, what we have termed as the ring of fire, they are saying that the fire itself and these landforms or features that tend to be existing in those areas, that they are brought about by the volcanic action or brought about by the tectonic reactions that tend to be happening within the Earth's surface. We are saying that the Pacific Ring of Fire has a total of volcanoes which range between 452 volcanoes, and most of them which are active, and the others tend to be also dormant, but anytime they may be lapsing. When you look about the areas that they mention, they talk about the Russia, that those areas are dominated with those volcanoes. They also mention about islands of Japan, then talk about the southeast of Asia, to the areas of New Zealand. So those are areas that they mainly talk about that have gotten those volcanoes. When we push on, we are saying that they also talk about the mid-continental belt. This mid-continental belt, it extends along what we have termed as the Alpine Mountains or mountain system in Europe. So they cut across North America, then go to Asia Minor, then come to Iran, Afghanistan, then Pakistan, then Eurasia Mountains, the Tiber, then talk about the Pina, then talk about the Shina, and also the mountains of China and the Eastern Siberia. So those are areas that tend to be having those belts, or what you have termed as the continental belts or the mid-continental belts. These ones are zones that have got large volcanoes, and also they are associated with the earthquakes of shallow origin, simply because they are just next to the coast, and these earthquakes tend to appear deep because of their movements. They are saying that the deep focus earthquakes are almost absent in the belts, and they're saying that about 20% of the total earthquakes of the earth are recorded in this belt. They are within the regions of the Alpine Mountains, Mediterranean Sea. Then talk about volcanoes, Mountain Atlas, that is in Turkey, then also other areas. So those are what we have termed as the mid-continental belts. When you move on, you have what the mid-Atlantic belt. And these ranges, all these are ranges composed of dissected spreading segments that are 10 of kilometers long. These ones are offsets by transforms of faults that tend to be originating from the Earth's interior onto the Earth's surface, and also the non-transform offsets. In other words, that others tend to be originating from within the Earth's surface, but not from the magma chamber, but they tend to be created horizontally or laterally. So those are some of the few things we can talk about the places. Now let us go and look at the volcanic features. Under the volcanic features, we have what we have termed as extrusive volcanic landforms. These extrusive volcanic landforms are formed from materials thrown outside during volcanic activities. These features tend to be existing onto the Earth's surface after the material is being thrown to the Earth's surface. The material thrown during volcanic activities, they may include the lava flow. I'll talk about what we have termed as pyroclasts, debris. Then talk about volcanic bombs, ashes, dusts, gases. And the gases, they are saying have what we call nitrogen compound, sulfur compounds, then also minor amounts of chlorine, and also hydrogen and argon. So those are the materials that tend to be happening. Then the features, you have what we call the volcanic features, vents or fissures. These ones, the conical vent, this one is a narrow cylindrical vent through which magma flows outside violently. A volcano vent are commonly known as composite or secret volcanoes. So these ones, for them, they are just say a narrow cylindrical vent through which magma passes through to reach the Earth's surface, from the Earth's interior onto the Earth's surface. The other thing we are talking about is what we have termed as the fissures. Fissures, also known as volcanic fissures or eruption fissures, is known as is a narrow inner volcanic vent through which volcanoes then or material is blown out onto the Earth's surface. The other is what we have termed as the mid-ocean ridges. These ones are all these are volcanoes that tend to be occurring within the areas, and these ones, this is a system of mid-ocean ridges that tend to be moving 770,000 kilometers along the surface or although the ocean basins. These extend from a distance of about 7,000. We have mentioned about it. These ones tend to cool slowly, and also they flow for a longer distances. They are saying that the lava separates through the surface, or it may separate through the sea floor. The others they talk about, they are the composite volcanoes or composite types of volcanic landforms. These ones are there are types of volcanoes, or conical or central type of volcanic landforms. These ones, they are in form of large quantities of pyrocrust materials, ashes that are found within the area where eruption has taken place. They have heights and most common volcanoes have composite cones. They are often strocones, and even they talk about their quantities that appear to be large in their quantities as they are given there. So those are some of the volcanoes are displayed to you there. Then you have what we call a shield type subpredo volcano. This one are mostly made up of basalt, and their type is it is in form of fluids. Once it erupts, then it forms what we call volcanoes, and not steep, but all the material tend to be flowing with ease. They also erupt, or they are less explosive. In other words, they are not violent when it comes to them. For them, the manure tends to be spreading, as you see that illustration. Then you have other caldera lakes. These ones are also formed after magma or after eruption. Magma has secured the place. In other words, a crater filled up with water. At times, it creates what we call the caldera lake. Those are some of the caldera lakes that they are talking about. After blowing off the surface, or an opening is left onto the top of the mountain, and then when it rains, it's filled up by water. Then you have what we call the cedar cones. These ones are steep, cylindrical or conical hills of loose pyrocrust fragments, such as volcanic sinkers, and then cedars, then volcanic ashes, which build around the volcanic vent. In other words, the material tend to be accumulating around the vent to give us volcanic cedars or cylindrical cones. When we move on, we are going to be looking at another thing that we shall be talking about. We have now the intrusive features there, where we shall be picking up from next time. Look at the intrusive volcanic landforms. What do they form at the end after eruption has taken place? For now, I beg we stop here, where we shall be picking up from next time.